Today we're going to talk through the 2014 calculator multiple choice section and work through some questions, talk through some different ways of doing it, and so on. As I go through these, I'll be looking over at my answer key just to make sure we're all on the right track and not getting the wrong answers as we cruise through here. Okay, let's get going. So question 76, we have a particle moving. We have equations for, not equations, we have definitions of equations for S, for T, or V, and for A. So the position, the velocity, and the acceleration. The question we're looking for is the average velocity. So when I hear the word average, I'm thinking a couple different options. We have average value, and average rate of change. So which one are we looking at? Average velocity. It could be average rate of change. So I could do change in position. So S of t. So in this case, S of 8 minus S of 2. Change in position over change in time. There's one way I could find the average velocity. I could also find the average velocity by doing an average value. Remember what average value equation finds? It finds the average value of whatever function is inside the integral. So average value is 1 over b minus a. So in this case, 1 over 8 minus 2 times the integral of a to b. And then whatever function goes next is the value you're finding. So in this case, I want average velocity. So that would be my equation. So let's look at which one I see. Letter A. Nope, that's the, let's go through what are we looking at also, that'll help us. 1 over 6 looks like what I have right here, 1 over 8 minus 2, right? So 8 minus 2, I can write that as a 6. So I can compare to what I have written down there. So this is average acceleration. Question B is average position. So those aren't the right ones. Well, there's letter C, that's the one we just talked about right there. So I know that's my answer. What's letter D? Average acceleration. Change in velocity over change in time would be the average acceleration, the average rate of change of the velocity. And then question E is just change in velocity. Okay, so it's pretty important that you can go through and identify what each of those mean. Question 76 in the books. 77. Sine is given by a function is given by that equation, sine of that mess. It's the antiderivative for f of x. They want me to evaluate the integral from 1 to 2 of f of x. So in order to evaluate the integral, we take the antiderivative, right? So this expression, integral of 1 to 2 of f of x dx, is going to be the integral or the expression evaluated from 1 to 2. Now, I could type that big mess into the calculator, but it's a lot of chances of making a mistake. Let me just do some things in my head. So I know when I plug in 2, I get 2 squared, which is 4 plus 1 is 5. So I get the sine of 1/5 minus the sine. Plugging in 1, I get 1 squared plus 1, which is 2. And so I get sine of 1/5 minus the sine of 1/2. So let's jump over here to our calculator. Make sure you're in radian mode. Upper right hand corner, I see radian mode, looking good. So I go trig, sine 1/5. Let me get, let me get to a scratch pad. There we go. Try that again. Let's go sine. Now you can do a couple different things. I could do 1 divided by 5, or right here I can go over here to the second divided by and get the fraction horizontal bar. I like that a little better. We don't have to worry about if we need parentheses, if we have more than one expression on top. So I like that one a little better. Jump over, minus the sine. Again, I'm going to go control divided by to give myself a fraction bar, and I go 1/2. But I could also, at that point in time, I could have done 0.5. We could have done lots of things. All right, sine of 1/5 minus sine of 1/2. I'm in exact mode. Go to approximate, we get a negative 2.0, etc. And I see letter A, which looks good. Okay? All right. Number 78. Function f is a differentiable function, and it's increasing. Super important that we can translate a verbal description into a calculus notation. Function f is differentiable, okay, and it's increasing. That means that f prime is greater than 0 for all. Make sure we see the key phrase all, okay, for all real numbers x. So the graph of f has exactly one point of inflection. Definition of point of inflection, where my second derivative is 0 and where it switches signs. Second derivative 0 and the second derivative switches signs. Super important we have that and in there. Of the following, which could be the graph of f prime, the derivative of f. Which of the following is the graph of f prime? Well, we just said right here that I want f prime to be greater than 0. So my graph is f prime, needs to be strictly above the x-axis. Letter B, out. Letter C, out. Letter D, out. Only options, A and E. Second criteria, has exactly one point of inflection. Exactly one point of inflection. Where is my second derivative? 0. I need to tweak my definition I said earlier. Or undefined. Where is my second derivative? 0 or undefined. And where does it switch signs? My second derivative is 0 at a max or a min of the first derivative, or at a cusp corner of the first derivative. Letter A, I have one max min. It switches signs right there, and it has just 1 point. So right now A looks like a good option. Question E has 2 points inflection, has 2 max mins. Answer, letter A. 1 max min of the first derivative makes it 1 point of inflection. Okay. Question 79. A vase has a shape obtained by revolving the curve given about x equals 0 to x equal, not about, from x equals 0 to x equals 5, about the x-axis. Okay, so let's just sketch a quick graph of what this thing looks like. You don't have to, but I think it's important. So typical sine curve being shifted up to, so it looks something like that. We're not going all the way, so I probably could erase that a little bit. We're going to shut it down right here at 5. And then we're revolving it about the x-axis, so it's going to come down here, and then, whoops, then it's going to look something like that after we revolve it. Okay, so there's what I'm looking at. And now back to how do you find volume? We're going to integrate from 0 to 5. What do these shapes look like? Well, they're circles setting in here because we just revolved it. We generated a circle. And we revolved it on the x-axis. So my radius is the distance from the line I revolved around to the curve. My radius is the y value because I'm revolving it horizontally, which makes vertical slices. Okay. So I'm revolving it around a horizontal line is probably a better way of saying it than revolving horizontally. But I revolved it around a horizontal line, and so I got vertical circles sitting in here. So my y value is the radius, and in this case, the radius is simply the y value. Had we revolved it around like y equals 2 or y equals -1, we would have to compare it to that line of revolution. Okay, that's for a different question. So my integral is pi times the radius squared. But then I'm doing volume, so I have a thickness of dx. Now, all this notation, not important for multiple choice. It is important for what we're doing, and it's important for the free response question when we have to relay what we're thinking. But for this question, I wanted to write it out so you can see it exactly like it should be written if you were on a free response question. Okay, let's grab our calculator and let's do a quick calculation. So I'm going to go pi. Several ways I can get to the integral button. I'm just going to use the calculus feature. Underneath here, I like using numbers. I'm going to click on 4. Excuse me. I'm going to go to 3. I'm going to integrate from 0. I'm going to integrate to 5 of, notice I need parentheses because what I'm about ready to type in here is more than one term being added together. So I have 2 plus the sine of x. And I'm going to jump outside that thing. I'm going to square it, and I'm going to write a dx. Notice that what I typed into the calculator is exactly like what I have written on the screen, which that's one reason why in the multiple choice, even if you don't have to, it's sometimes good to do that so that you know exactly what it should look like. Okay, one more side note, make sure you're in radians. Must be in radians. I would do that at the very beginning of the test or before I even got to the test. Okay, I'm going to go Control Enter, and I get 80.115. Looks like letter E. 80.115. It is letter E. Okay, there we go. Question 80. The table above gives selected values of the function f. Function's twice differentiable, and the second derivative is always greater than 0. Which of the following could be f prime of 3? F double prime is greater than 0. What does that mean? So let's just take a couple derivatives. Well, I can't actually take a derivative because it's just tables. So how do I do a derivative in a table format? I have to do average rate of change. So we just did that back in question 76, or the first one on this one. 3.6 minus 2.4 is 1.2. 3 minus 1 is 2. So my average rate of change, or my average first derivative, is 0.6. 5.4 minus 3.6 is 1.8. Again, this is 2. And so 1.8 divided by 2 is equal to 0.9. All right. My second derivative is greater than 0. What does that mean? Well, my function right now is increasing. And if the second derivative is greater than 0, it means it's increasing at an increasing rate, right? This means it's concave up. So if my graph, I guess I don't need the xy axis, but if my graph were concave up and my function's increasing, that means I'm on this side of the vertex or of the minimum, okay, if it was a parabola, it'd be a vertex. And so I know it's increasing at an increasing rate. Okay, so which one of these could possibly be the answer? So if I look at question A, option A, could my first derivative be 0.6 at x equals 3? So in between the 0.6 and 0.9, right, in between the two average rate of changes I just found, is where my 3 lies. So then if my second derivative, or my first derivative was 0.6, my second derivative would not be greater than 0. My second derivative would be equal to 0 because it's the same as the starting point. So the 0.6, if this was also a 0.6, that would be the same, and in my second derivative, that wouldn't work. Letter A, out. 0.7. Could it be 0.7? Well, it looks pretty good. It goes up by 0.1 and then it goes up by 0.2. So my second derivative is increasing. That's good. Looks like B could be it. Could it be 0.9? Well, no, for the same reason I just said the other one couldn't be, because then this second part over here, if this was 0.9, then this would be the same, and that's not good because then it's not going to be greater than 0. It'd be equal to 0. So 1.2, that definitely is not it because then it went down, right? So this is 1.2. It decreased from 0.6 to 0.2 or to 1.2. So 1.5, same reason. Answer, letter B. Now, on the real test, you're probably not going to do what I just did. If you find an answer that makes complete sense for efficiency, you're going to move on. Okay, but because this is a tutorial type way of doing it, I want to just make sure we explore all options. Number 81. At time t equals 0 years, Forest Preserve has a population of 1,500 deer. Rate of growth of the population is given by that equation. What is the population at time equal 3? I know a rate. I want an amount. I'm going to integrate. However, I know an amount also at time equals 0. So I start off with 1,500 deer. Write that so you can read it. I start off with 1,500 deer. To that, I'm going to add the amount of change from time equal what I know to time equal where I want to end up. At time equals 0, there's 1,500 deer. The integral from 0 to 3 tells me the change in the population from time equals 0 to time equals 3 from my derivative, my rate of change equation. And I don't need notation, but I should get good habit of good notation. Okay, grab your calculator. We're going to go 1,500 plus menu number 4, number 3. Integrate from 0 to 3. We'll talk about that in another video. There's times when you're going to define R of t, but we're only going to use it once, so I'm not going to do that for this problem. Second E, nope. Not second, just E. Raised to the 0.23. You can use T or X. I'm going to use X. Calculator doesn't care. You could use T also. Just double checking that I see something weird sitting right there. Just double checking that everything looks good. It's super important you do that. And I know you're in a hurry on the AP test, but just an extra second to make sure everything's typed in right. Looks like letter D. 81 does look like letter D. Okay. Question 82. Figure above shows the graph of f prime. When you do these, super important that we understand what graph is given. This is a derivative graph. Which best describes the graph of f? Given the derivative, being asked questions about the original or about f. Question A. A relative minimum. Does it have a relative minimum? Relative minimum. Must know the first derivative test. You must know the first derivative test. Relative minimum says it switches from decreasing, so it's negative first derivative, to increasing, a positive. Is there a point on the graph where my values of derivative go from negative to positive? Yeah, right here. My derivative is negative to the left. My derivative is positive to the right. So there's one relative minimum. One relative maximum, just the opposite. It goes from increasing to decreasing. It goes from a positive to a negative first derivative. -2. So there's one relative min, one relative max. 3 points of inflection. We already said this earlier. Points of inflection occur where my first derivative have relative max or mins. Where does my first derivative have relative max or mins? Right there, and right there. Looks like question 82 is A. If I were on an AP test and I were taking this test for real, I would not keep going. Okay, because I verified every single one of those. And looking at my answer, yes, answer is A. Now, We could walk through every single one of those, but I think we talked through that well enough that we don't need to for this particular problem. Question 83. Let f and g be continuous functions given by those big expressions. What is the value of that big mess? Okay, so I'm going to write that mess, and then we're going to break that mess down. Okay, so we have an integral from 0 to 3. I don't need to rewrite it. I'm going to separate those right now. I'm going to stick the constants out in front because I can. Using good notation, make sure I bring the dx. But again, I don't have to because it's on the free or it's a multiple choice section. But all right, that's what I got. I'm going to jump up into my descriptions and see what I can just easily replace. Well, this was an easy one. I'm close. I have 0 to 3. They have 3 to 0. So I'm just going to switch that. And if I rewrite this as the integral from 0 to 3, then this negative 7 becomes a positive 7. So this becomes a minus 3 times 7. We okay with that? Integral from 3 to 0. When I switch it from 0 to 3, the sign of my answer switches. So it becomes a positive 7. All right, this other one requires a little bit of work. Integral from 0 to 3. So let's just look at a graph. So what I'm given is the integral from 0 to 6. So some curve of f of x. Integral from 0 to 6, this area is 9. But if I go from just 3 to 6, this area is 5. Well, that means this area must be 4. So this becomes 1/2 of 4. That makes sense. 1/2 of 4 is 2. 3 times 7 is 21. And 83 is letter B. Good to go? All right. 84. Regions A, B, C are given, bounded by the function and the x-axis. Area of A is 14. Let me just stick that in there. Area of A is 14. Area of B is 16. And the area of C is 50. Okay? What is the average value? Once again, can I rewrite verbal descriptions as a mathematical calculus notation? Average value, 1 over b minus a. Well, b minus a would be 8 minus 0 in this case. Integral from 0 to 8 of f of x. So now what is this integral going to represent? The area underneath the curve. So that's pretty easy. So it's going to be 14, I'm going to jump up here, 14 plus 50, because those are my positives, minus 16. Area underneath the curve is negative, area underneath the x-axis is negative, area above the x-axis is positive. That becomes what, 48? So this is 1 over 8 times 48, which is 6. Okay, be able to translate verbal descriptions into calculus notation. Average value. As soon as you hear that, boom, throw down the average value equation. All right. Question 85. Particle moves along the x-axis. Its velocity is given by that equation. Total distance traveled. Integral of the absolute value of velocity is equal to distance traveled from 0 to 2. Type that mess in just like it's written. I'm going to go menu, number 4, number 3, 0 to 2. Okay, remember my template button, so I'm going to push this button here. Absolute value. It's not liking it. There we go. It was sticking for a second. Once again, I'm not going to use the division button. I'm going to use second division or control division so that I can get a horizontal fraction bar. If you don't do that, you must put parentheses around your top and bottom expressions. Okay, but by doing it the way I did it, I don't have to, because it keeps it up in the numerator, and then it jumps to the denominator when I want it to. Trying to talk and type at the same time is probably not a good thing to do, but I'll double check my work before I hit enter. All right, we are integrating the absolute value of my velocity equation with respect to x from 0 to 2, hit enter, and I get 0.927. Looks like letter D. Yep, letter D. Pretty straightforward question. Took us a little bit of time because I talked through a lot of stuff, but pretty straightforward question. Question 86. Line L is tangent to the graph of y equals e to the x at that given point. Find the positive value of k for which the y-intercept of L is 1/2. In order to find the equation of a line, I need two things. I need point and a slope. I'm given the point already, right? Already given the point. So my slope then is just y prime, and my slope at the point x equals k is just y equals e to the k. Good to go. Y minus y1 equals m times x minus x1. Doing a little rearranging so that I can get into y equals mx plus b. I'm going to distribute that so I get x e to the k minus e to the k plus e to the k. Well, this mess right here is sitting where my y-intercept is supposed to be. So I need to write an equation of what I want. And I want that to be 1/2. Fair enough. Grab a calculator. We're going to go y equals, or nope, sorry, we're going to go solve. Menu, number 3, solve. And we're going to solve negative e to the x. We could make it a k. We could do whatever we want. I'm just going to go to x's. E to the x. And if I called k in the first bit x, then I got to call the other k x plus e to the x. And that needs to equal 1/2. I'll go 0.5 because it's a nice neat number. And looks good, comma x, because that's what we're solving for. And you can do a numerical solve, but in this case, I'm going to do, I already did solve. And I was just going to say that you're going to get an error message sometimes, or a warning. Not an error message, a warning. And if I click on that, it says it's a numerical solve and it may not be accurate, but it is. I've not seen one of those numerical solves. Won't say haven't ever seen it, but they're 99.9% of the time accurate. So this is 0.768, etc. Looks like letter B, and we're good to go. If I'm doing a trig function, it'll probably come up in another video, but if I'm doing a trig function, then I'm going to throw in a such that over here. But again, that's for another video. But there's a way of limiting your solver to only solve in a given interval. But we can talk about that on another video where we're doing calculator stuff. Let's just keep this one rolling. Question 87. Differentiable function f has a property that the derivative is less than 3 everywhere between 1 and 8. F of 5 is 6. Which of the following could be true? Okay, I'm going to make a little graph. F of 5, 1, 2, 3, 4, 5 is equal to 1, 2, 3, 4, 5, 6. I'm going to have to get way up there to 13, but it's all right. We'll see if we can make this work. So f of 5 equals 6. The derivative is less than 3. The slope of my function f is less than 3 for every value between 1 and 8. From 1 clear out here to 6, 7, 8. My slope is less than 3. F of 2 is 0. Could that be a possibility? If I put a point right here at f of 2 equals 0, is that an option? What's my slope? It's up 6. My rise is 6. My run looks like, what's that? Can't count. 3. My run is 3. So 6 divided by 3. Wow, what was that? My 6 divided by 3 is 2. Is 2 less than 3? Yes. All right. Question 1 is an option. Get rid of what I just graphed. Next point. Didn't want that to happen. Right. Next point. 6, negative 2. When x equals 6, y equals a negative 2. Is this point an option? Well, let's calculate the slope. My slope is negative. Clearly a negative is less than 3, so I don't even have to calculate what it is. I know it's negative. So letter 2 is also an option. Next one, f of 7 equals 13. F of 7 equals 13. We're way up here, right? So f of 7 equals 13. What's my slope? 13 minus 6 over going to 7, so over 2. And so my slope is 9 over 2, which is 4.5. 4.5 is not less than 3. Sounds to me like we got letter C. 1 and 2 work, 3 does not. Question 87 is C. Okay. Question 88. The graph of the differentiable function f is shown in the figure above. H of x is given by that. Order the following. Okay, let's just walk ourselves through. H of 2. H of 2 is the integral from 0 to 2 of f of t. H of 2 is the area under the curve. I'm just going to go positive and negative right now. At some point in time, we may have to go more. Area underneath the curve is positive. So h of 2 is greater than 0. Okay, what is h prime of 2? Well, h prime is the derivative of h, which is the derivative of the integral, which is simply f. So h prime of 2 is simply f of 2, which looks like 0. Okay, h double prime of 2. Well, h double prime of 2 is the same thing as f prime of 2. And f prime of the 2 is the slope of my curve at 2, which is decreasing, so my slope is negative, so this is less than 0. Looks to me like the biggest is h of 2, the smallest is h double prime of 2, and the derivative is in the middle. Looking at those very carefully because there's a lot to look at. I see letter E. 88. Letter E. Yep. Really important that you can take the derivative of an integral. It's going to show up a bunch. Question 89. What is the area of the region enclosed by the graph of y equals e to the x minus 2, y equals sine x? We definitely could at this point in time type those two functions into the calculator to see what they look like, but I think we know, or I think we need to know. So e to the x minus 2, exponential growth curve, horizontal asymptote cruising across here. So there's my exponential growth curve, y equals e to the x minus 2. Sine starts at 0. Does its sine curve? So which one's the largest from 0 to where they intersect? The sine curve. Okay, so I need a couple things. First thing I need to know is what's that intersection point? So grab your calculator, go to menu, go to solve. I'm going to change that. Sorry, I'm going to do something different. I'm going to delete that. I'm going to do a numerical solve. Numerical solve gives me the first solution it comes to. So in this case, it's a sine curve, so there could be more than one, right? There's not going to be, I don't think. this comes back around and hits, but I just want you to see numerical solve. So we're going to do e to the x minus 2. Nope, get out of the exponent. E to the x minus 2. Set equal to the sine curve we're going to do that with respect, or solving for x, not with respect to x, but solving for x, and get my answer. Okay, now we have largest value of sine, so I want to integrate. So we go menu, number 4, number 3, integrating from 0, jump up here, whoops, jump up here, grab that thing, stick it in, and I'm integrating sine, missed, integrating sine of x, jump out, minus, now super important right here, the second term has 2 terms. So that negative sign needs to go to both, or I'm just going to stick the entire expression, excuse me, e to the x minus 2 inside that parentheses, and now I'm going to integrate that. Okay? Make sure you have that parentheses, otherwise it will not come out right. Looks to me like we got letter C. Number 89, letter C. Make sure you have the parentheses, super important. Okay, question number 90. Particle moves along the line so that its velocity is given by that equation. When is the speed of the particle increasing? When is the speed of the particle increasing? Okay, there's a couple ways of doing this. One way is fairly calculator dependent, fairly heavy calculator dependent. And I guess the other way is also, but I'm going to do something a little different. You may have thought this also, but here's what I'm going to do. I'm going to type in my velocity equation into the graph. So I have negative x raised to the 3rd power plus 2x squared plus 2 raised to the negative x. Okay, so there's my expression. Hit enter, and there's my graph. Okay, let's answer the question. When is the speed of the particle increasing? Speed increases when velocity and acceleration have the same sign. Speed increases when velocity and acceleration have the same sign. This is my velocity graph. Velocity graph is positive until I hit this point right here. I don't know what that point is, but looking at my options, it looks like 2.057. Okay, I'm not going to calculate it. It looks like 2.057. It can't be 0.177. That doesn't make any sense. And it can't be 1.26. It's clearly right around 2. So I know that my velocity, sorry, keeps doing that. My velocity is greater than 0 when t is less than 2.057. Okay, acceleration is the derivative of velocity. So my acceleration is negative on the left-hand side. So from wherever this is going to be, negative whatever, to this one looks like it's 0.117 or 0.177. So it's negative from here to here. It's positive from here to here. So that's like 0.177. That looks like 1.256. Now, you can't get away with what I'm doing on the free response question. But since it's multiple choice, I'm going to use my multiple choice options to help me answer the question and save me a lot of work. Okay, now if we needed to find those values, all I have to do is go menu, and I can go analyze graph, I can go max min, and so on. Okay, but I don't need to do that. Okay, so now let's answer the question. My velocity is positive up here. So my acceleration is positive between here and here. So when X is, or T is between 0.177 and 1.26. So letter D and E. Letter E. Also, though, my velocity is negative down here, and my velocity graph is decreasing, so acceleration is also negative. So from 2.057 to infinity, it is also the same signs, so my particle is increasing. Speed of my particle is increasing. Okay. Number 91. Looks like my window got off a little bit. Number 91. Let f be the function defined by all real numbers such that the derivative is greater than 0. My function f is increasing, and my second derivative 0 is increasing at an increasing rate. F is increasing at an increasing rate. My first derivative is positive. My second derivative is positive. My curve is on the right-hand side of a concave up graph. It is increasing at an increasing rate. Okay, let's keep going. Question A. -3 to -4 to -6. It's decreasing. A's out. Letter B. From a -3 to -1 is 2. From -1 to 3 is 4. From 3 to 19 is 16. It is increasing at an increasing rate. Letter B looks like the right option. So I'm going to circle B, but let's just check the other ones. -3 to 0, it went up by 3. From 0 to 3, it went up by 3. From 3 to 6, it went up by 3. That one's out. This one goes from -3 to 5. It goes up by, what's that, 8. Then it goes up by 6. It's increasing, but it's increasing at a decreasing rate. That one's out. And letter E is out because it's just going down and then it goes back up. So the answer is letter B. Okay. Question 92. Table of values is given. F, G, etc. They're all given. All right, let's jump to the chase. G of X is an inverse of F. G of X is the inverse, F to -1, of F. Okay, so I highly recommend you memorizing what I'm about ready to show you, but here's how you do it if you don't have it memorized. So if G and F are inverses, then the composition function of F and G, so I'm going to put, nope. The composition of G and F gives me X. Taking the derivative of that then, F prime of G of X, chain rule, derivative of the outside function, times the derivative of the inside function, and the derivative of X is 1. Doing a little rearranging, I'm solving for G prime because that's what I want. So G prime, I'm going to go ahead and stick a 4 in there, is equal 1 over F prime of G of 4. If you forgot how, or this derivative, if you don't have it memorized, you can always derive it. Okay. Solving that thing, G of 4, cruising up to my table, G of 4 looks like -2. So this becomes 1 over, slide that up a little bit. This becomes 1 over F prime of a -2. F prime of a -2 looks like 4. And so this becomes 1 over 4. Did I get a negative sign in there? Nope. Oh, there we go. Letter D. I didn't see it. All I saw was B, and I thought I made a mistake. Number 92 is D. Okay. There is the 2014 No Calculator multiple choice. Hope it helped. And if it did, don't forget to check out all the other recordings for the other 3 parts of the 2014. And then good luck on your test. Thanks for watching. If you found these videos helpful, you can find other videos in my series. And don't forget the reviews where I talk through a bunch of practice problems. Have a great day.